My name is Ezra Kissel. I'm from Indiana University. I'm demonstrating our service called IDMS. It's the Intelligent Data Movement Service. The goal of IDMS is to provide a persistent, long-running distributed storage service that runs on Genie that can be used by experimenters for uploading data and then downloading it at a later time across slice lifetimes. And one of the key things that we're doing now is integrating with something called the Earth Observatory Depot Network. That's the EODN in front of EODN IDMS. And we're working with our collaborators at a MerrickView consortium to integrate the IDMS functionality with community instantiated depot resources that can be made part of this global experiment. So what they're primarily interested in is disseminating earth science data. And what happens here is you typically have very large data sets that are not very frequent. So what EODN is trying to do is being able to stage that data at locations within the network that makes it easy for researchers and the tools that they need to access that data quickly and effectively. So what typically, I can go to this poster here to basically show what our given workflow looks like within the EODN IDMS experiment. So what happens is we have an application server that's interested in the data that is being distributed within the depot network, and it subscribes to our global services, which tracks metadata about the files that are being staged within the depot network. At the same time, we're constantly harvesting data, the earth science data from the USGS Landsat ground network, and then we have a persistent service called the EODN Harvester, which stages that data within the depot network. So typically you'd want to stage the data close to where the application server will want to access it in terms of round trip time or latency, so you can get better performance for downloading once it's available. So when the data is available, it's published to our global services, which sends a notification to the application server that it can then quickly download that data and perform the processing and upload to the given application, which is then perform things like visualizing it over a map overlay, or for additional analysis that can then be, those files from the additional analysis can be pushed back up into the depot network for use by other community members. So that's it in a nutshell. And what we've done is spend a lot of time working on a web GUI that allows the user to see what's available inside the depot network. So you can do searches and find matching scenes within the network and be able to download it directly from the web GUI. We also have a number of client tools which allow the application servers, as I mentioned, to subscribe to the data so that data can be pulled automatically. At the same time, we have the ability to browse what's currently there. So you can basically look at a file structure and see what all the data sets that currently exist, and they can be, as I mentioned, downloaded directly from the web interface. And we also have the ability to do depot tracking. I think I have a tab here that shows you where all the active depots are within the EODN network, and we're able to check out their network utilization, their usage, to see how well they're performing. So, we can see system utilization, network in and out, and so forth. So the other aspect that I wanted to briefly mention is using IDMS as an experimenter tool. So that's how IDMS originally started. I spoke just now about the real Earth application use case. But one of the other things that we're actively working on is the ability for users to attach to the IDMS slices and be able to work with the data that they upload. So on my laptop here, and I know it's going to be a little difficult to see, I have a user slice that's attached to the IDMS experiment, and we're able to run a script. There's a bunch of tools that get installed in this user RSpec, and that allows you to, in this case, upload a large amount of data that's staged on the given experimenter slice, push it into EODN IDMS, and we're able to go to the web interface and take a look at some of that data that's staged. So for instance, these are the files that I'm actively pushing in to IDMS. We're able to click on them, be able to visualize where they are in the depot network. So you can see that files are actually staged across multiple storage resources across the United States. You're able to see where the mappings are, and what we're working on, and one of the goals is to be able to manipulate the distribution of the data so the user has explicit control of being able to place it in geographic locations where it makes sense for the ingestion of that data at a future date. I'm not sure if the download visualization is currently working, but if you can see, we also have the ability to visualize all the downloads as they come in. Unfortunately, it just stopped. I think I can start it again. But you can see, as active downloads are being performed, we can actually see how they are being distributed and pulled from the different depots in the network. So that's the current state of the project. We're working a lot on the web GUI front-end components and the ability for the user to interact with the data that they're uploading into the network. So finally, I'll just mention that we have further information. If you want to zoom in on the poster there are a bunch of links that describe the project and the Genie experiment, and there are resources on the Genie wiki page for experimenters to be able to go online and test this out for themselves. So thank you very much.